thing. But first I figured because it was a talk about SQL Server security, and here's way too much about me, one line at a time. Right, I work for with a company called SQL Skills. They have a website, I have a blog. There's my email, there's my Twitter account, and various and sundry other things about me, which have nothing to do with this particular presentation. Although, like I said, I did do the security best practices white paper, so for a while. So I'm going to talk about new features in SQL Server security only because people like new features. I like to talk about new features too, so much so that I'm known as the shiny new feature guy, sometimes derisively, but I'll tell you about the new features in security for the last 3 releases. And then we'll talk about SQL injection, authentication and authorization, and a little bit about encryption, and if we get to it, auditing. So in SQL Server 2008, they added the ability to encrypt an entire database, and that's called transparent data encryption. Once you encrypt an entire database, you have the ability to write encrypted backups. Having said that, this was an enterprise-only feature, the encrypt the entire database feature. And so in SQL Server now, there is actually a tool called SQL Server Backup to the Web, which is a free tool. It turns out you can not only back up to the web, I should show you how the tool works. You can not only back up to the web, but you can back up with encryption from any release of SQL Server and, well, back to 2008 and maybe 2005, and with any addition of SQL Server. So having said that, even though it's not part of the presentation, that sounded interesting enough so that I should show you this tool. Really, you're not supposed to do stuff on the fly. Okay, so you download this tool and you install it. And basically it puts a little hideous looking icon on your, sorry, we need magnification. Puts a little hideous looking icon on your tray that looks like it's a cloud with the database next to it. And so when you bring it up, it says Microsoft SQL Server Backup to Windows Azure Tool. And what I want to do is actually not back up at all to Azure because I don't have any network. I didn't think I would need it. We'll set this to actually back up from any edition of SQL Server to any, just a regular share or a regular directory. So what you do with this thing is you add rules to it. So we'll add a rule that says whenever I back up to a specific path on the local machine, or let's just do all paths to the local machine, with a backup pattern that's something like star.bak. So any backup that starts with or ends with BAK, sorry. What it actually can do is redirect to Windows Azure Storage. So this is a way to get people to use Windows Azure Storage. And you can do this with any release back to 2008. But you can also just use it with local storage. And so if I'm going to back up any local backup, it's going to redirect it to local storage. Well, what do you mean redirect? Why do we need that? So if you go to the next part of the rule, this part of the rule says it will actually enable, or can actually enable encryption, and it can actually enable or disable compression, which is interesting when you use Windows Azure Storage, but it's even more interesting in the fact that this works with any of the additions. So if I enable encryption, I have to put in a password. Password cannot be empty. I wonder if it can be password. Son of a gun, it can. Okay, well, anyway, the password can be password, and then you can enable compression at the same time. And basically how this works is rather interesting. So you make up this rule, there we go, and now that you have this rule, the tool goes away. And when you actually go to do a backup, this backup automatically is encrypted, and how would you think this would work? Especially with older versions of SQL Server. So here's how it works. There. So if I go ahead and go into the database and just pick a database at random, a small one, so it won't take forever, like the pubs database, and back up this database, there we go. It comes up with the usual backup thing. And I want to back up to not something that's C Azure backups, but T local backups. So we'll just do a full backup to the local backups directory. So we don't want that one, because that's actually set to point to Azure. We want this one. We decided that people really wanted to have, and this is pubs.bak, people really wanted to have something that would back up automatically. And actually, let's call this pubs3.bak, just in case I've done this before. And the only problem with this tool is it won't work in low resolution. Well, go. Okay, good for me. And it's got that destination fine. Okay, great. And we don't want this one in here. And now when you go ahead and back up, notice I'm using the regular backup tool, and I've specified encryption. So what happens if I go out and look at what I've backed up and where, it turns out that what I backed up and where is a PUBS3 backup that looks like a regular backup, but there's actually a level of indirection, and there should be someplace on my file system something called PUBS3 ENC, which is the encrypted backup. And so basically it looks like you have a regular backup, and you can restore from a regular backup, and as long as that tool is in place, it knows where to get the encrypted compressed one. So that's actually kind of cool, I think, with any release of SQL Server and any addition of SQL Server. Okay. So that was for enterprise. This is for everybody. And built-in auditing was another feature in 2008. People have written all kinds of auditing things in the past, and usually when they went to try and get the auditing certification, they said you should do auditing from SQL Trace, from SQL Profiler. And the problem with that is it's a separate tool, it's really not secure from the people that are using it. And so in SQL Server 2008, they actually added built-in auditing. And so that is, again, an enterprise feature as well. External key management. So when SQL Server instituted encryption, one of the things that they did was store the encryption keys on the database with the data. And that's not a security best practice. You're supposed to store the keys separate from the data. And large organizations have these things called external key modules that basically do key management. It's like a box that looks like a set-top box for a TV set. And so they made it so that you can use these modules, and they have a couple of these modules that work with SQL Server. Again, another enterprise feature. 2012 had a lot of new features for SQL Server security. So a bunch of new permissions and some user-defined server roles. You could always have user-defined database roles, but this is user-defined role on a server basis. Default schema for Windows group users. I'll talk about schemas later on, because I actually really like managing SQL Server with schemas. And contained database. A contained database is a database that you should be able to move from place to place to place. And one of the problems with moving databases from place to place to place is that the logins are actually on master database. And so you have to move the logins separately. And this was a database that you could move around, and users that could actually use their user ID to log into the database. Key algorithm changes. So they introduced encryption in SQL Server 2005. And when they did that, there's some old key types that they allowed. So they started to migrate toward the new key types and get rid of the old key types. Key management enhancements. You can basically take public-private key pair and actually put it out to a stream of bytes so that you can take that stream of bytes and move it to another database. And auditing enhancements. So the problem with the original auditing was that it was an enterprise-only feature. People didn't like that. So they divided the feature into server-based auditing and database-based auditing. And they let server-based auditing do a sort of less granular version of database auditing. So basically, if you know how to code the statements, you can pretty much do everything with server-based auditing that you can do with database auditing. So that means you can, and server-based auditing is available from any scoop, any version of SQL Server, Enterprise or Standard or Express or anything else. So that's supported in any scoop. In 2014, they didn't do a lot. But what they were trying to do in 2014 was to make it possible to have users that were not super users that could manage the computer, manage the database, without having access to certain parts of it which they shouldn't have. So one of the things that I'm going to talk about is never to run as SA or anybody else at sysadmin, but it's actually not good to administer the machine that way either. This is as the man sits here and does demos off of as he's logged in as SA or super user. So there's a super user login, and you can add a user that's part of that login group. And that login is called sysadmin. And if you're sysadmin, all security is off. There's nothing that you can keep away from a sysadmin at all. When they get to the part in the code that says, check to see if the person's able to do this, if it's sysadmin, they just skip that code. So basically, once you have sysadmin, you have everything. So the premise was, make a permission that's really high permission, like sysadmin, and the one they have is alter server, and then make permissions that you can take away from that person, that you can deny that person. So basically, the first one they had to worry about with this was impersonate any login, because even if you have the SA account disabled, if you're able to say execute as login equals SA, then you're sysadmin anyway, and so it doesn't make any difference. Also, they tried with select all user securables. They said this one was for auditors that needed access to user securables, but it was also to take away from DBAs that shouldn't be in user securables. It turned out that that one has a couple of rough edges. One is if I do have alter server, I can actually, or control server, I can actually make myself DBO of a database. And DBO of a database can bypass security in that database. So that's kind of interesting until I make myself DBO of a database. And this one also, unfortunately, doesn't allow you access to anything that's not part of the sys schema. So if it's part of the sys schema, you can access it, but anything else you can't access. And the problem is a lot of the ancillary tools that go along with SQL Server, like SQL Agent and SQL Mail, they actually live in schemas other than the sys schema. So there's kind of a couple of rough edges on this now, but that's what they introduced for SQL 2014. And again, encrypted backups without TDE. That's the little tool I showed you before. And that's a standalone tool. You don't have to have 2014 to get it, and you can just download it today. So what I'm going to talk about here is just sort of more application-y security stuff to start with, and then I'll feed into the authentication and authorization part of SQL Server. So basically, connection strings. Believe it or not, in SQL Server 2005, they thought that one of the main problems with SQL Server was that all the demo code had hard-coded connection strings in the demo code that used SA and no password as the login. And people were too either lazy or didn't care to change the connection strings. And instead what they'd do is they'd actually change the SA password to no password so the demos would work. So starting in 2005, they basically rewrote all the demos that came with SQL Server so that they didn't go to SA with no password by default, and put those connection strings in a configuration file to sort of show everybody that really your configuration file should have your connection string, not your code. So it's a best practice to keep connection strings in a configuration file rather than program code. And if you have the config file in .NET, you can actually encrypt those so that even if you have passwords that are in those files, you can encrypt them to not be able to be seen. And then finally, for now it's called Microsoft Azure SQL Database. I didn't change all of my Windows Azures to Microsoft Azure last Thursday when they changed it again. So if you're using the Microsoft Azure SQL Database, that's a database on the cloud. No, I'm not going to do cloud without that. That's the database that's up on the cloud by itself. And the deal is that you authenticate to that with a user ID and a password, because right now they don't have active Windows Azure, Microsoft Azure Active Directory hooked up to that. So basically when you do that, what you do is there's a pre-authentication exchange where they will actually send you back a certificate so that you can use that to encrypt a response back. And what SQL Server normally does is if you have a certificate installed, they will use that certificate and that will be secure. You do have to have a certificate on the other side to be able to talk to it. If you don't have a certificate installed, then what they will actually do is use a self-signed certificate. And for people that aren't familiar with that term, a self-signed certificate is one that's actually vouched for by the machine itself. So basically I could take Bob's pirate server and put it out in the middle of the internet and give you a self-signed certificate and say it's anybody I want. And then if you encrypted that with that and sent back your user ID and password, I now have your user ID and password. So there's a connection string parameter that it always should be used if you're using Windows Azure SQL Database, and that's trust server certificate equals no. If somebody sends you a self-signed certificate, which is what the server certificate is at that point, you don't want to trust it if it's from Windows Azure. And actually, if you're on the internet, you shouldn't have that type of authentication either, because it's just insecure. Everybody okay with that part? Good. And then SQL injection. So it turns out the #1 cause of problems in web applications, which are most applications these days, are SQL injection problems. And you've probably heard of this, but I thought I would tell this story anyway. Everybody always, has heard of the story. You guys have speed cameras here. And so basically there's speed cameras in Seattle and there's a lot of them and people get tired of speed cameras. And so there's a guy that actually had a license plate printed up that says 1 semicolon drop database tickets, just in case they happen to feed his stuff into this database with this. By the way, I heard late after that, nobody laughed. I'd heard after that, because everybody's heard that there is such a real person too. I heard that this is not a problem with MySQL, because MySQL doesn't allow multiple statements in a batch separated by semicolons. But with SQL Server, it actually is a problem if you actually concatenate user input. And the big thing about this is don't concatenate user input to make a SQL statement. Right now, if you do concatenate user input to make a SQL statement, and you're running as SA or sysadmin or whatever you want to run as, pretty much all bets are off. They can drop database tickets. And by the way, I guess the guy didn't have the ability to put drop database tickets with rollback immediate, because that'll get rid of all the people that are on that database before it drops it. So you can certainly do that even though people are using the database. So a best practice is, and it's funny because the DBAs are the ones that enforce this best practice, but the DBAs use string concatenation all the time. And I'll show you why coming up in a bit. But this is usually caused by concatenating user input to form a SQL statement, and it results in execution of whatever the user types in. Now, some of the results is that you can guess passwords, you can obtain passwords, you can obtain data that you're not supposed to obtain, you can obtain database metadata, although starting in SQL Server 2005, as long as you have the right low privileged account, they will not have access to database metadata, except for specific tables that you have the ability to access. Again, this is another one where if you're using SA or DBO, all bets are off. And of course, drop database objects, drop database tickets. So some of the common patterns, I'm just going to talk about 2 of them. One's the ending a statement with user input. So again, that's the obvious one. But another one is actually executing a conditional statement from user input. So if I have a select ID in table with an input of 1 or 0 equals 0, and they put in 1 or 0 equals 0, then basically what they're doing is they're reading your database table, right? Because now you have the ability to read everybody out of the table. Of course, that's if your graphic user interface has the ability to display it as well. But hopefully you don't overflow the graphic user interface. So the best way to get rid of almost all SQL injection attacks is with parameterization. They will not execute parameter values. And parameterization is at its lowest point. The ability to, rather than say select star from authors where name equals and then concatenate the name in with a plus sign, what you want to do is say select star from authors where name equals @name and pass in the name as a parameter. They will never execute parameter values. One of the best things about, Link to SQL, actually Entity Framework does this, but not always, is that they always use parameterized statements in Link to SQL. Therefore, they claim you're safe from SQL injection with Link to SQL. If you have things that can be parameterized and you parameterize things, then you're not going to execute user input at all. And you can either use stored procedures, parameterized queries, but as long as you parameterize all your input. You can also use SP execute SQL. SP execute SQL is a way to execute a parameterized query on the fly. And as long as you don't concatenate the user input into the query, you can actually specify the parameter values and execute it as a dynamic statement. This is actually not the same as doing this with exec. Exec is actually using string concatenation and doesn't have any knowledge of parameters. But the thing that these 3 all have in common is parameterized statements. And parameters are usable even if there's multiple SQL statements in a batch. If you want to put in a batch of SQL statements with 2 parameters on one statement, 2 on the other, I can put in 4 parameters and it works just fine. And again, do not concatenate user input in stored procedures. Now again, the ones that always do this are DBAs. And the reason why DBAs are the ones that always do this is because there are things you can't parameterize, and this is usually what a DBA wants to use as a variable. Again, it is okay to use user input concatenated as long as you know who's going to execute the procedure. But if you have that thing out on the web and you're concatenating user input, then that could be a problem. So you can't parameterize DEL. You can't parameterize a create table statement, nor can you parameterize table names or column names. So I wrote something for somebody a little while ago with spatial data, and it was something to do some kind of great spatial calculation. And he said, great, I would like to rewrite it so it can be used with any table, and I just pass in the table name and the column name. And I said, that's dynamic SQL with string concatenation. And he said, well, it should be able to just use the column name and use the table name in the statement that I want to. Can't be done, not in SQL Server. You actually do have to add in the table name and so forth. Now, an obvious way, if you want to be able to pass in the table name to check for SQL injection, is actually look in systables and make sure that table actually exists. But do remember that you want to parameterize that statement as well. Right, select star from systables where name equals @name, or I think it's a two-table join to do that. So make sure that that table exists, make sure that that column exists, and once you check for existence, well, it's a little bit better. Passwords for opening keys. So in SQL Server 2005, they put in encryption, and one of the problems was that you would have to key in passwords to open keys. So if you want to be secure from the DBA, the only way that you can be secure from the DBA is actually have something that's encrypted by a password. That's actually a password, not a certificate, and not a, not an asymmetric key. If you have something that's a certificate or an asymmetric key, then the DBA can just impersonate you and then use your certificate. Again, that's another good reason for the deny impersonate any user privilege. So the problem was, if you had a password, there was no way to parameterize the statement that says open the key with password equals blah. And so you actually had to pass the password in. But if you have to pass the password in, is it secure at all? And of course, no, it isn't. So they made a rule that said, okay, if somebody was doing a trace, then they wouldn't trace anything if the statement had the word password in it. That always confuses people when they're trying to do troubleshooting. It's like, well, where did my statement go? Oh, it happened to have the word password in it because that was the name of one of the columns. So that works until you have a packet sniffer involved, and then all bets are off. So some of these things just can't be parameterized. What we had to do with this, passwords for opening keys, is we actually had to send these over the network encrypted, and then also put the word password gratuitously in there so they don't appear on a trace, and then actually do the concatenation in client-side code so that they're not going to do it in server-side code. You can parameterize in clauses. It's very strange, but you can do that. And the problem with it is you have to have as many variations of the in clause as you have possibilities of numbers of things you can select. So therefore, if I wanted to say select start from authors where a L name is in, and then have an in clause here. Okay, so we'll say, let's see, white and green, and that should be enough. You can parameterize this, but not in the way you would think. Everybody always wants to pass in a hash table or pass in an array and actually get that to be the values in here. That you can't do. But you can do, just make sure this works, okay? And I'm going to have green. Oh, because I misspelled the word green, Bob. That's why. There. Okay. So you can parameterize this. It would look something like this. And again, you wouldn't normally do this in a procedure with declare to prevent SQL injection. So say password out of that 40, and then we'll declare @b varchar 40. And just for the sake of argument, I'll just initialize them here too. So set A equals white and B equals green with 1. There we go. And set B equals green. And then you can actually parameterize them like this, which is not the best, but it's better than using string concatenation. And that should work just fine if I didn't miscode something. Oh, good for me. Okay. The only problem, again, is that now I have to have one parameterized version for one answer, and one for two answers, and one for three answers, and so forth. But indeed, it does work. You just can't pass in a variable length array and have it just parameterize everything, which is what everybody always asks for. So you can parameterize data clauses, and you can write catch-all queries with every possible column that might be needed and use case statements, but that's sort of strange as well. So there are two ways to go about trying to get rid of bad characters in input, user input. And one way is the way that everybody uses, and one way is the way that I like to use. So the way that everybody likes to use is filtering characters. So try and go through and write this big, complex, hairy algorithm that actually filters out the characters that aren't supposed to be in table names. And filter out all the characters then that you don't want in table names that your naming standard says you never use. And maybe use quote names and things like that to make sure that you quote things rather than have them do SQL injection with it. Now, you can filter that on the client side by actually just using regex. If you have client-side code, middle tier code, and your code is between the internet and your database, then you can use regex in client-side middle tier code to make sure that you have the right pattern. You can limit the number of characters in input fields. The overflow exception is always fun for allowing security. And really, I like to filter them by looking for valid input, not invalid input. Invalid input, somebody always comes up with a lovely algorithm that's supposed to get rid of all invalid input. And it turns out that really what you want to do is look for valid input, because you can always solve a puzzle of how do you put in invalid input. Filtering on the server. So again, this isn't as good, but you can use quote names and replace as a good start. Watch out for comment characters or semicolons or hexadecimal input. One of the things that people forget when they actually look for certain characters is you can pretty much execute anything in hexadecimal. Right? If you can put in the hexadecimal input, then you can just concatenate hexadecimal input in there, and all your special characters you're looking for, all bets are off. And reject bad input rather than trying to fix it up. If somebody's put in that bad input, then let them try again. However, there was a story apparently of somebody who's broken the database in every company he's ever worked for, who has a last name of Null. And that's, you can't say that, no, we're not going to hire anybody named Null, or we're not going to let them into their website. So be careful with that. A comprehensive list of characters have not been determined, and SQL injection is possible with just ordinary old characters. Analyzing error messages. So one way to do SQL injection is to actually build a SQL injection that works by analyzing error messages. And of course, because most web applications will not put out error messages, that's a good thing. But you can also figure out how long an error message would wait to come out by actually injecting a wait for in there and then figuring out how long you have to wait. If it's an error, it'll come back immediately. If it's good input, then the wait for will actually work and you wait for a while. Look for grouping errors, look for type mismatches, especially with hex, and don't include SQL statements in error messages. This, of course, is not helpful for debugging, but most of the frameworks will actually let you turn that on and off for debugging purposes. And another thing that they do that upsets people when they're trying to debug SQL login failures all the time is that SQL Server does not provide you the reason for a login failure. What you get when you have a login failure is, I believe, message, and I could have this number a bit wrong, 18456. And 18456 is you can't log in, something bad happened. And it doesn't tell you that. It says login failed for so-and-so. And of course, that's because it's fairly easy to spoof quick login failures by figuring out what's wrong and then going on and trying to fix that thing. So you don't even want them to know what happened. People that get upset about not having specific login messages do realize that if there are login errors, SQL Server will log the real login error in the SQL Server log. And so if you can read the SQL Server log, that's where you want to look for the error, not in the user's error message. Of course, you don't have to tell them that. You can say, read me the error message over the phone, and then go look for the real login error. We're really okay with that. Okay. So now I want to go on to authentication and authorization. So authentication is the ability to log on to a specific application or database or operating system. And basically, authentication just identifies you to the application. So who am I and who vouches for my credentials? if you have a SQL login, then who you are is whoever they put in the database, and it's the database that vouches for your application. Better to have the Active Directory vouch for your application if you can. So types of authentication in SQL Server, you have Windows logins and SQL logins. Again, Microsoft Azure SQL Database at this point in history only supports SQL logins. Windows logins are preferred, and in fact they're so preferred that when you set up SQL Server you have two choices. One choice is to only allow Windows logins, and another choice is to allow Windows logins and SQL logins. But there is no choice just to allow SQL logins. So Windows logins are preferred if you can at all do it. And Windows logins are preferred because with Windows logins, they really never send the user ID and password across the network. Basically, you sit here with the GUI screen. When you type in your user ID and password, that doesn't go across the network. They send a message with what's called a nonce across the network. They actually use the nonce to encrypt an encryption key, send an encryption key back to you. Your side can unencrypt that key, and then you don't send anything over the network unencrypted. You send a hash of your password over the network. And then if they can verify that hash by hashing your password on the database, then you get to log in. So with Windows logins, you never send the password across the network at all. With SQL logins, you will, send the password across the network. Starting in SQL Server 2005, they refused to allow you to send an unencrypted password across the network. But I've actually seen somebody do this, even in SQL Server 2012, 2014, by using an old version of a JDBC driver. So do use the latest version of drivers so that you don't even allow this, Windows won't even allow, SQL Server won't even allow this anymore. And so that's the reason why Windows logins are preferred. Again, you can use NTLM or Kerberos. Kerberos is always better because it works with delegation. Delegation is when you want to have them authenticate to your web application and then pass that identity to your SQL Server. And they have something called constrained delegation these days, where if you're going to use your password, you're going to delegate your password to the middle tier application, you can tell the middle tier machine that only this application is allowed to use my password to log on to somewhere else. And you can tell this machine, the actual database machine, that only the database is allowed to receive delegated credentials. Delegated credentials gets rid of the most common problem when using Windows credentials, which is the double hop problem. I can send the identity from here to here, but Windows identities by default and always in NTLM are only good for one and only one hop. So the canonical example of this is when you have a web application on the same machine as your SQL Server application, because you have a very small application. People authenticate to the web application, and the web application uses your credentials to log on to SQL Server, and that works fine when they're both on the same machine. Then your application gets popular, and you can't use your credentials to log on from your machine to machine A, and then have that log on to machine B. So when you separate SQL Server from the web app, this breaks. So if you start with a little application, don't forget that delegation is a special case in SQL Server. And you do have to use Kerberos to have delegation, which means you need an Active Directory. NTLM is not supported without an Active Directory. Kerberos is not supported without an Active Directory. Everybody okay with this? And if you're troubleshooting Kerberos logins, remember that local logins are always NTLM, unless you use a specific version of the ODBC driver and a specific PSN to say that I would like to log in with Kerberos. So don't try and test Kerberos authentication by logging in on a local machine. It's not going to normally do it. Special logins. Again, the special login that everybody knows about is SA, which is the SQL Server super user. And SA is actually a member of the sysadmin fixed role. And the sysadmin fixed role, basically, all bets are off. Now, everybody was thrilled by saying that SA can be disabled or renamed. But all that disabling the SA login does is disable the fact that you can use this login to log into the database. Disabling the SA login does not make it unusable. So you can't log into the database with that login, but it's perfectly valid for an administrator to say, execute as login equals SA. And even if the SA login is disabled, that will still work, and that will still execute as SA. So disabling the login isn't as good as you think it is if you have people that can do impersonation. And everybody's heard of what I mean by impersonation? Okay, execute as, whatever. Renaming actually can cause problems with some upgrades. I think they fixed that problem in the latest upgrades, but you can also rename the SA account. Basically, this is sort of a security by obscurity method. That means if somebody's trying to log into your system, there's two things they have to guess rather than one. And I've seen people do this as well. So rename them and disable them, but remember, people can still impersonate them if they have the ability to impersonate. Windows administrators. So you can be a Windows administrator and you're granted sysadmin privilege by default until SQL Server 2008. In SQL Server 2008, they took away that privilege by default. So Windows administrators are not by default SQL Server administrators. A lot of people have this problem when they're actually trying to install SQL Server on client machine, and the client machine is actually using UAC with Windows 7 or Windows 8, and they bring up SQL Server Management Studio with their own ID, and they think, I'm an administrator, but UAC is going to knock that down, and you won't be able to do anything you think you should do if you think you're an administrator that is part of the sysadmin group. Everybody okay with that? That's like another common problem. Okay, SQL Server 2008 requires one admin at install time, so you do have to have an account that actually can be used as an administrator. There are also logins mapped to certificates and logins mapped to asymmetric keys. And this is sort of an interesting thing if you're an ISP. And so I'm trying to figure out if I should do this as a demo or not. Okay, let's do it as a demo. So in SQL Server 2005, they introduced the ability to write store procedures and functions in .NET code. And so these store procedures and functions that you write in .NET code are actually cataloged directly to the SQL Server database, and they live inside the SQL Server database. So imagine that you write a .NET stored procedure that actually goes out to the file system and trundles around in the file system and goes out to the registry and trundles around to the registry and so forth. So you write that at home, you catalog that to the database, and then you take your database and you go into an ISP and say, please put this database on your instance for $40 a month or whatever they charge. And so when that person puts that database on their instance, that also means that they put that CLR code on their instance. And by the way, CLR code in SQL Server actually executes by default as the service account. That's the account that you're using to start SQL Server. So the service account is the one that you can see here in the configuration utility. And by default, starting in 2012, they make the service account a low privileged account. The service account should never be should never be an administrator type account on the local machine. But if you look in here, what they've started to do is use, I don't know if you've heard of the operating system feature they call service SIDs. It's a SID that is applied to a specific service. So the account is different on machine A is machine B is machine C. And so in this case, they're making up an account called SNT Service MS SQL Server. And basically that's a low privileged account. And then at install time, they will give it the exact privileges that it needs. So the nice thing about that is if you use a low privileged account like that, rather than administrator or local system, then even if somebody got in and tried to trundle around the registry, if you don't have access to parts of the registry, then they don't have access either. So CLR runs as this by default. Now, the other thing that they did for ISPs is to say, okay, there are three types of CLR code that you can run. Safe code, what they call safe code, and safe code doesn't leave the instance. Anything that leaves the instance, like goes out to the outside world, is not safe code to SQL Server. External access code is code that goes out and tries to access internal resources, and it tries to access internal resources like the file system or the registry by using the service account, or you can impersonate somebody specific. And then finally there is unsafe code. Unsafe code can do anything and everything it wants. Right? The premise with allowing unsafe code was that only the DBA can allow unsafe code, not any old person can allow unsafe code. And so unsafe code can do things like shut down SQL Server, play with other processes on the machine, probably not something you want at all. So to keep people from putting unsafe code in SQL Server, they instituted this concept. And the concept is that if you have unsafe code, to catalog unsafe code or external access code to SQL Server. Do I have this? Yeah, this is our DLL right here, unsafeassembly.dll. And the unsafe assembly is a real easy assembly. All it is it's unsafe because they have a global static variable, and they consider global static variables to be unsafe. I'm sorry, mutable static variables to be unsafe. If you can change a mutable static variable, you have to have your own lock system, and SQL Server doesn't want you to have your own lock system. You interfere with their lock system. So I have this unsafe assembly here, and if I make a new database, the foo database, there we go. If I create database foo and then use foo, the way that I'm actually going to try and put this code in is to actually say create assembly. Well, actually, I think they have this as a canned demo rather than watch me type. I'm the world's slowest typist. And so if this is another one where you have a limited amount of time, you probably want to do this. There we go. Security overview. And by the way, I'll put all these demos up where you guys can get to them. Let's see, what am I looking here for? There is keys and assembly. So if I create a database called foo, then one of the things that I'm going to try to do is just catalog that assembly. So create unsafe assembly from this assembly on the file system with permission set equals unsafe. And if I'm in the foo database, it won't work. In fact, it gives you a really nice long error message that says, unsafe assembly is not authorized for permission set unsafe. And you have two choices of things to do to authorize that assembly. One of the things that you can do is not a security best practice, that is to actually make the database trustworthy. Trustworthy database, to me, there's a lot of different things that it does, but trustworthy database to me in one sentence is not a best practice, but it does say that the sysadmin of the instance, the owner of the instance, trusts the owner of the database. If the owner of the instance trusts the owner of the database, in other words, if it's an IT shop and both are the same person, that's fine, right? But if you're an ISP, that's absolutely not what you want to have as people with trustworthy database permission. So instead of trustworthy database permission, you can set up this key system. In other words, I can say from here, alter database foo, either with or set, let's see, set trustworthy, let's guess, set trustworthy on. And set trustworthy on will say foo is a trustworthy database, and then if I'm in an IT shop, I could perfectly well do this. There we go. So it's cataloged. Now we can delete it or drop it, so we can try this again. There we go. And I'm not sure how many people use assemblies these days, but it was popular when it started. There we go. And so now, if we turn trustworthy off, we're going to be in the same situation again. And the only way to do this, if you don't have an administrator that will set trustworthy off, is something that should set off some bells in an ISP's head anyway. So you take your database and you go in and you say, could you please put this on your instance? And they say, fine. If the database is not trustworthy when they attach it to another instance, then your code just doesn't work. Even if it's already in the database, even if it's already cataloged and all the stored procedures are already cataloged. So to make it work, you must do this. You must go to the ISP. But first of all, you must sign your code. So you sign your code with a code signing key. And then you must take the code signing key and you must give it to the ISP and have them do some interesting things with it. So everybody knows how to sign code with this code signing key in .NET? Okay, let's just make, oh, I don't have actually Visual Studio installed. It's a Visual Studio project setting, and you say sign the code, and it signs it with an asymmetric key, and then you give the asymmetric key to the other person. So I'm in the master database. I knew there was some reason why I wanted Visual Studio for this demo. And then we're going to put the asymmetric key in the master database. So to put a key in any database, the key has to be encrypted itself, right? There's no reason to put an encryption key in a database if somebody can take a copy of that database, figure out where the key is, and read it. So to encrypt that key by default, we're going to create something called the master key in the database. And so this is the master key in the master database. The master key has to be encrypted by a password, and that's actually a valid password, right? Strong password 1. It has uppercase character, lowercase character, and number. So there we go. And now I have a master key in my master database. So what I must do is I must take my code signing key and I must give it to the ISP and say, could you put this code signing key in your master database, please? And that should set off some surprising bells in that person's head. But if they do that, right, once they put that code signing key in the database, do I have the key available? No, okay, I have to have the key available. So once they put that code signing key in the database or actually put it in from the DLL, then that's not enough, right? Just putting the key in the database is not enough. You have to create a login for that key. Because you can't assign permissions to keys, you can only assign permissions to people, logins and users. So you create a login for that key. And then once you create a login for that key, you grant unsafe assembly permission to that login. And once you've done all that, and if you can convince an ISP to do this for you, you deserve to trundle through their system, right? Once you've done all that, then you can create the assembly just fine, without trustworthy permission or without anything else. Now, if you are an ISP and you want to be convinced, be aware of the fact that if you find that the assembly is doing anything nefarious, you can deny unsafe assembly to that login at any point in time, and the code just stops working instantly. So that's a way to allow unsafe coding in an ISP situation without just making the database wide open and setting it as trustworthy. Any questions about that? Okay. So logins mapped to certs, logins mapped to asymmetric keys are used specifically for that reason and also for service broker. They added a lot of security features in 2005. Many of them were just added for a service broker feature that they added at the same time. Server roles. So SQL Server includes some predefined server roles, and you can see those when you make a new login or when you look at an existing login. So if I go into Object Explorer and make a new login, you'll see that there's predefined server roles. And one of the big sort of frustrating things about server roles was that you couldn't make up your own server role. So if I make a new login, Bob, and I can map it to specific server roles over here. These are the built-in ones. You can't change them. And normally you really shouldn't be using them except for special cases. So SQL Server in 2005 actually put in a permission-based system for almost everything. So you don't have to have these special roles to do things, you just have to have the appropriate permission. That being said, there was a couple people that didn't participate. One was DBCC. So DBCC still requires that role, and also some of the SQL agent stuff still requires that role. Otherwise, you shouldn't have to use this role at all. Again, this is where you assign somebody sysadmin, and then the rest of the roles really are unused. You know, try to stay away from those. Bulk admin used to be necessary for bulk copy, but now there is actually a permission you can assign called administer bulk operations. And everybody is a member of the public role, you can't take them out. So one of the sort of frustrations was you couldn't make up your own server role. But in SQL Server 2012 and above, you can make up your own server role. So 2012 allows you to do this. Also, again, it's not just the SA login that you have to worry about. It's anybody in the sysadmin role. Anybody in the sysadmin role that you put in the sysadmin role, and if you run a web service or a web application website as sysadmin, shame on you, right? You deserve everything that you get. Because if you're sysadmin, basically, the sysadmin role can do anything at the server level, and sysadmin is automatically DBO of every database. Normally, DBO is a concept with two different meanings. One is the database owner, and you can only have one and only one database owner. So you can see the database owner in the GUI by actually looking at the database, and you can see that the database can have an owner, and there was only one place to put the owner. Under Files, there's the owner right there. My owner right here is SA. So That's the database owner concept. But there is also the concept of every person who is sysadmin is also the equivalent of DBO on every database in the world, and there's nothing you can do to drop them from that ownership. Right? So there is only one database owner, but sysadmin is the owner of every database. Everybody okay with that one? So basically, once you've made somebody sysadmin, all bets are off. You can't deny any permissions from a sysadmin. So, for example, if I put myself in as a sysadmin here, that's it. There's no security I can put on me at all. So I'll make a login for me, and we'll make that person sysadmin. There we go. And we'll put in a password, which you can probably guess what it will be. There. And when I make myself sysadmin here, sorry, the server role sysadmin, that's it. There's nothing you can do to touch me at all. Right? You can go in and you can try and say deny something to me. So deny impersonate any user to Bob. So to Bob. And basically that has no effect. Oops. If I can spell the word impersonate. Impersonate, what's the problem with that? Huh. I don't know why it doesn't like that. Okay. Deny, goodness, let me just pick one that I have that I can actually spell here. Well, it should be impersonating any user should work, right? So we'll go back a couple of things, and because apparently I can't spell it, darn. Hopefully I can spell on the slide. Oh, impersonate any login, of course, Bob. Good. So deny impersonate any login to Bob. There we go. Did I spell impersonate right the last time? And that appears to work once Bob logs on. So we'll actually log onto the system as Bob. That's strange. We should get an error there. So we'll log onto the system as Bob, and that's a SQL login. And we'll log in with my password. Of course, that's the login. Come on. Local server. Bob. Login. There. Now what I should be able to do, oh, right. When you make up a new user, by default, SQL Server will make you change the password. Before you accept this default, make sure that you have an application that has a password changing capability. Otherwise, your people that you just put in are going to come to you and say, could you change my password? It says it's the first time. Right? This is one of these strange things that is, oops, okay. This is one of these strange things that is different in DDL than it is in the GUI. The GUI makes it all too easy to get yourself into a situation like this. DDL actually has the opposite default, which is kind of weird. There we go. Now if I'm actually logged in as me, and I can see I'm logged in as me, if I am sysadmin, and let's check to see that we are sysadmin, because I wasn't too happy that it didn't come up with the right error message. Okay, so we are sysadmin. Then I just denied impersonate any login to Bob. So I am Bob over here, and let's execute as login equals SA. If I can get away with that. And SA might have to be unquoted. No, that still works, right? So you cannot take away anything from a sysadmin, even if there's a bug that says that they don't put up the error message. It should have come up with an error message at that point that says you cannot deny anything to SA, sysadmin, or yourself. You're not allowed to do permissions for yourself. But notice that deny impersonating the login didn't do that very well. If I go back and take that sysadmin ability out, away from Bob, then I can deny him whatever I want. Everybody okay with that? Okay. We need to go forward to where we were. So sysadmin basically ignores the permission system. And the only thing that you really have to be sysadmin to do is DBCC and some SQL agent jobs. Never run a web application or never run a web service as sysadmin. That's just too much power. If you somehow do that and allow concatenation of SQL, then they can knock off your database. You okay with this? So database users. So SQL Server is kind of different if you're used to a database like Oracle with one database per instance. SQL Server can have many user database per instance. And so they have this bifurcation of logins and users. Login is what you have to identify yourself to the system, and then you can grant or deny permissions to logins at a system level, at an instance level. Database has users, and you can deny or grant things to users. And each database contains its own users. Users can map to logins, and users can be Windows logins, SQL logins, Windows groups, and even for Service Broker, again, in 2005, you can even have a user without a login. Service Broker uses users without logins so that they can use them to extend privileges to, but you can't use them to log in. Everybody okay with that one? Okay, good. By the way, be really careful. Once upon a time, I wrote, and everybody approved, a best practices white paper that said a good thing to do is actually to use Windows groups as logins and Windows groups as users. It turns out that there is a possible problem with that, and here's the possible problem with logins and with users. It works nicely as far as if you use Windows groups as a login, then anybody that's added to that group gets to log in. And when they are not allowed to log in, then you just take them out of this group. But here's the problem with this. So I'm going to go into my Windows, and I'm on a local machine. I'm not actually on a domain. So if I go into Control Panel, Administrative Tools, and Computer Management, I'm going to add a user, or a Windows user, there we go, named Mary. So we'll add a new user named Mary. And fine. Let me guess what the password would be again. Okay. And we won't say that she has to change her password on next login, and create that, and that works fine. And then we'll add two groups. One group is the people that speak French, and they would be the French group. So we'll add French group, it's French users, and we'll add one for, and it says what users do you want to add to that group, and I'll add Mary. You can probably see where I'm going with this already. So we'll add Mary to that group. There we go. And then we'll also add a group for English users. And we'll add Mary to that one too. So Mary is a French user and also an English user, depending on what language she wants to speak at the time. Maybe Mary's from Canada. Right? We'll find that and put that in. There we go. Okay. So now she's a member of two groups. Let's now go ahead and add a login for both of those groups. One of the things about login that's interesting is login language is specified as part of login. So if I go ahead and add a login, new login, and I add a login for the Windows authentication, and the login name would be French user, and so I can go search for that if I want to. I'm going to send one for English user as well. I just want to see if I have to have the machine name, otherwise I'll copy and paste that in. Where's the, sorry, object types, I want groups, there. Okay, so now we'll put in, we should have, where are the French user, did I not hit groups? Because I didn't. Search now, there we go. And we should have the English user and the French user. And we'll put both of those in one at a time as a login. And when I put in the French user as a login, you might notice that besides the user being put in and what groups they belong to and what securables they have access to, there's also a default database and a default language. If you do not put in the default language for everybody is the language of the instance. Every instance has a default language. But in this case, we are going to choose to put a default language in for our French users. So we'll put in that they speak French. Now, most people think that this is just a way to figure out what the error messages come out in, what language the error messages come out in. But now we'll make up another login for our English users. And of course, we do need the machine name too. All right, so we'll do this one more time. And here's the, you probably see where we're going with this. Anybody want to answer the question before I ask it? No, nobody's going to be psychic, right? Okay, what is he doing? And we'll make that one use the default. There we go. Now, when Mary logs into SQL Server, does she speak French or does she speak English? Because according to this user setup, she's a member of French users which speak French and a member of English users which speak English. In fact, if they use the day, month, year date format in France, I'm not sure if they do or not, I believe they do though, what happens to Mary at the 13th of every month? Well, all her dates start to become invalid, right? Because they think they're keying in the date with the date format that corresponds to the language that they speak. Everybody okay with that? So be very careful with that. By the way, what language does Mary speak if we do this? It's actually the language of the login with the lowest ID. So it's the one we put in first. Really? So that's, very, deterministic, right? So do be careful with those because that is a way to do, mess things up. Okay. So you can do the same thing with database users and schemas, and I'll talk about that. And what brought this to mind was that a database user can be a Windows group as well as a regular Windows login. So there's special database users. Again, DBO ignores the permission system. And so any database owner or anybody that can make themselves database owner has the ability to ignore the permission system in every database. They can do that. There is also a special user called guest. Guest is turned off by default. And basically what happens is, notice we have a username French user and we have a username Bob. None of these users have actually been mapped to a database yet. So if the French user is able to log in, what databases do they have access to? And the answer is the only databases they have access to is database where guest is enabled. By default, guest is disabled, and there are auditors that want you to delete the guest user. You cannot delete the guest user. You can only disable the guest user. In fact, you can play with your auditors for a long time about this. You can delete the guest user with the drop user command, which appears to work, and then when you go and look at it, the guest user is still there. So be really careful with this. A drop guest user will actually disable guest user. Everybody okay with this? And the canonical excuse for anything is what we got this from space, right? The idea of a guest user. By the way, in Microsoft Azure SQL Database, there is no capability to add a login named SA or sysadmin or anything else that has a special meaning. And DBO is just the person that actually owns the Azure account. Everybody okay with this? So there's also special users that own certificates for service broker auth. Because again, service broker uses certificates, you can't assign permissions to a certificate. And just like we made a login for the asymmetric key that we use for .NET, we can make a user for a certificate, that person that owns the certificate to give permissions to. Okay. So a user can be in one predefined role to any predefined role. They're always in the public role, and you can't take them out of the public role, but they can be in as many other roles as you want. You can also create your own user roles. In SQL Server 2012, they have a feature called Contained Database, and a contained database is a database where users can log in. And there's a couple different things that you have to enable to allow a user to log into a contained database. You first have to make a database with containment. That's a database option called containment equals partial. They never did implement full containment, so containment equals partial. And then you also have to allow, at an instance level, contained database users with passwords to log in. And then they can log in. Okay. Everybody good so far? Authorization. Authorization is basically mapping database privileges to a specific principal. And you can map them to logins, you can map them to server roles. The user-defined server roles can be assigned privileges. The built-in server roles can only have predefined privileges. Users can be assigned privileges. And users can also have database level and schema level privilege. And so when we get to schemas, I want to show you soon. I want to show you a trick that I like to use to make it easy to drop and recreate objects. Database roles, you have predefined and user-defined database roles, And so you can assign those privileges as well. And then this is a cute picture that basically says that, right? Windows groups can be principals that log onto the database, domain accounts, local accounts. SQL Server logins, they can be assigned to server roles. At a database level, you have users that can be assigned to database role or an application role or a group. I actually went through this deck and took out the concept of application role. Does anybody ever use this? No, application role. If not, forget it. There is really not a reason to use application role at this point in time. An application role is a role that you basically don't put anybody in. And what you do is in your application, you say SP-set app role. And once you say SP-set app role in your application, the person loses all their own privileges and only gets the permissions for this particular role. And it turns out that you can sort of say SP unset app role as well. They added sort of some security around this where you can say SP set app role with a cookie, so only the application knows what the cookie is. But the whole thing of putting security in user applications for a database is kind of silly. So when they introduced users without logins for SQL Server 2005, basically you can use a user without a login for the same reason. Right? Why would you ever want to use the same login for everybody in a web application? Everybody uses the same login in a web application. Why? Come on, this is the audience participation part. I know it's 10 after 5, and we're right before the party or the get together or whatever, but why do people use the same login for everybody in a web application normally? No. Because connection pooling works if you do. Right? Connection pooling only works when you log into a database with the same exact connection string, or at least the parameters in different orders. So normally if you have a web application, what they do is they always use the same login for everybody. If you use different logins for everybody, that means connection pooling doesn't work, but you can assign things in the database to specific people. So once I actually have this connection pooling working, and everybody signs into the database as the same person, how now do the auditors distinguish between different people? And so a way to do this is to actually use the execute as concept with users without logins. In other words, suppose everybody who's logged in is Bob, right? And so if the auditors come in and say, who changed this row, who changed that row, who called that stored procedure, the answer would always be Bob, regardless of who logged in. I can't tell one user from another. However, if I want to have my own application table with names of users and privileges that those users have in the application, or just names of users when people log in, what you can do is have an application-specific login, right? I'm going to log into that application and say Fred1, Fred2, Fred3. I connect to the database always as Bob, but once I've logged into the application as Fred1, once you get into the database, you can say execute as user equals Fred1. At that point, you are always Fred1 all the time that you're in the database. So then auditors can distinguish one person from another. Now you don't want that Fred1 user to ever get used in the database directly, so what you can make him is a user without a login. Make a Fred1, Fred2, Fred3 user without a login. Once they've done their application-specific login, map the logins to the users in your application. Everybody get that idea, or should I do that on the board?
Oh, so is that why again you don't advise using application rules?
Right, exactly. You can have that many application roles if you want.
Yeah.
But those things have to be set in the application themselves. You can have a login stored procedure that everybody does that basically just takes their identity in the system and and maps them to users without logins. Therefore, you can never use them outside of the application, and you can have as many as you want. Everybody okay with that? Okay. This is why you never need set app role anymore. And then what happens is you have these principals that are assigned permissions. And these are the ability to get to securables. And basically, what they tried to do in 2005 again was add a feature called all permissions are grantable with the grant verb. And that also means all permissions are deniable with the denied verb. There's a couple of problems with this. The super users don't go by the permission system, and neither do DBCC, right? And some of the agent things. But they're trying. So in SQL Server, there is actually a database security language with 3 database security verbs. In most databases, there is a database security language with 2 security verbs. Most databases have grant, which is a positive privilege, and deny, which is a negative, and revoke. There's no such thing as deny in most database systems, grant and revoke. And in most database systems, grant actually grants a privilege, and revoke revokes it. However, in SQL Server, there is also deny. And deny is a negative privilege that trumps all. So say, for example, I'm a member of 3 roles, the accountants, the auditors, and the users. If one of those roles is denied access to a table, but the other 2 are granted access to a table, a deny overrides all the grants that you happen to have. Everybody okay with that? And the reason why SQL Server put this in is this is the way Windows security works. If you think of giving somebody access to a printer, it works the same way. There's a deny permission that overrides all the grants you could possibly have. So deny overrides a grant. I'm trying to go a little bit faster here. So we talked about the refactored privileges, and basically that was the all permissions grantable. And then you have privileges at different levels of the database. So you can give somebody permission at an object level, at a schema level, at a database level. I'm going to skip some of these slides here as we go on. Users and schemas. Okay, this is the one I want to actually concentrate on for people that have to write applications. So most people that write applications, and many people that have written applications for years, don't use the concept of SQL Server schemas. In SQL Server 2000 and before, if you created a database object, create a table, who owns that object? You own that object if you create an object in SQL Server 2000 and before. If you create an object in 2005, who owns that object now? You don't necessarily own that object. The schema owner owns that object. So one of the things that you can do is actually group permissions in terms of schemas. Now a schema itself, if you just want to define schema, is a container, right, for database objects. It's an empty container which can contain things like tables, views, stored procedures, user-defined functions, things like that. And by giving permission at a schema level, you can save yourself a lot of hassle with permissions and managing permissions. Because once you give somebody, for example, execute permission at a schema level, you grant him permission to execute all the stored procedures in that schema. What's nice about that? Well, what do you sometimes have to do? Drop a stored procedure and then recreate a stored procedure? And people will go through this, well, if it's there, I want to alter it, else I want to drop it. And if you actually have permissions assigned at a schema level, you can drop the stored procedure, you can add the stored procedure, and because the permissions are at a schema level, the permissions stay when you drop and recreate things. So actually, I think with 15 minutes left, I want to do 2 more things. One is users and schemas, and the next one is the ability to have what they call, goodness, now I've lost the word for it. I'll get to it. Okay. So every user has a default schema. Goodness, ownership chains, sorry. We'll do users and schemas and ownership chains, and I think we're good for the day. Sound like a plan? Did anybody really want to do encryption in an hour and 50, or an hour and a half? Okay, so here we go. So a schema is a container for database objects, and a schema itself can be owned by a user or a database role or even an application role that we don't care about anymore. And you can see that objects are not normally owned by users anymore. Right? Let's go into just a database that ships with SQL Server, the pubs database. And we'll actually do a query in the pubs database. And we'll query something called systables. Right there. Okay. When we query systables, notice that every table has an object ID, which of course we know, and a principal ID. And notice that for every table, the principal ID is null. Principal ID is the owner of the table. And so does that mean in the pubs database that nobody owns any tables and the tables are sort of orphaned, owned by no one? What null is a special meaning that says, or a special value that says, if nobody specifically owns the table is owned by the owner of this particular schema. So these tables all live in the DBO schema, that's schema 1, and because they have no specific owner, which is the default, then they are owned by the schema owner of schema 1, which is of course DBO. So everything is owned by the database owner. Okay, so if I go in and I create a username Bob, actually I have a username Bob in here, so let's create a username Fred. I have very limited vocabulary of users, and without login, mostly because I'm too lazy to make him a login, but there you go. And we'll actually grant Fred create table permission, which sometimes people do. There we go. And once we've granted Fred create table permission, here's my question. Can Fred create a table? I've just issued these two statements. Can Fred create a table? And of course, you know at this point in history it has to be a trick question, right? The answer is no, Fred cannot create a table with those permissions. Well, I've just given Fred the ability to create a table, haven't I? Let's see. So we'll execute as user equals Fred. And by the way, this has nothing to do with the fact that I'm using execute as, I log on and log off or whatever, it's still the same. We'll execute as user equals Fred. And then once we're executing as user equals Fred, as Fred, we'll create a table and we'll call it food. That's fine, you can do that too. And then with the smallest number of characters I can type there. So Fred has the ability to create a table, but this fails. And basically what it's saying here is that Fred is trying to create a table with a one-part name, and when you use a one-part name, the default schema takes over. Fred's default schema, since I didn't assign Fred a default schema, is DBO. DBO is the fallback default schema. And so Fred is actually trying to create a table called dbo.foo. Now, when I'm trying to create a table called dbo.foo, notice the error that I get. The specified schema name, DBO, either does not exist, I'm pretty sure it exists, right? It does not exist, or you do not have permission to use it. So even though Fred has create table permission at this point, there's no place for Fred to create that table. There's no guest schema that anybody could create a table in, and he doesn't have permission to the DBO schema or the sys schema. So create table enough by itself is not good enough for Fred to create a table. We have to create a place for Fred to create that table. Or we have to give Fred the ability to create a table in the DBO schema. So first of all, let's revert back from being Fred, because you can't give permissions to yourself. And one of the things, if I want to, I can do is I can grant alter on schema DBO to Fred. And if I do that, now Fred can create tables in the DBO schema. Everybody okay? So Fred not only has to have create table privilege, but he has to have a place to create the tables. By the way, everybody has create table privilege in TempDB, so that's why you always see programs creating things in TempDB, right? Everybody has create table privilege there. Okay, so that's one way I can do it. What's another way I can do it? So another way I can do it is actually to make up a schema that's either owned by Fred or Fred has the ability to alter. So let's create a schema for that. So we'll create a schema. And schema would be Fred stuff. It doesn't have to be named after Fred. And then authorization Fred. Now as the DBO, I bypass the security system. So I basically can create my own schema owned by whoever I want. This one is authorization Fred, or I would have to actually create a schema owned by somebody else and give Fred the ability to put tables there. Everybody okay so far? So now because Fred owns that schema, let's go ahead and try again to create a table as Fred. And of course, Fred's not very good with SQL Server, so he's always going to create stuff with one-part names, and then fails again. And it fails again because every user has a default schema, and if you don't specify a two-part name, then the default schema for Fred, since I didn't specify one, is DBO. Okay, probably not good to say at this point in time, but DBO is the default schema. So at that point, what can we do? We can alter the user Fred to make Fred stuff his default schema, or we can make Fred use a two-part name. So let's make Fred use a two-part name at this point. There we go. And now Fred can create a table. And if we look at the create table statement, the tables that Fred can look at. So as Fred, he can only look at a subset of the tables. Those are the ones that he has access to. And everybody has access to the list of tables. But Fred only sees his own table. And notice that even though Fred created the table, the principal identity of that table is null. It is owned by the owner of schema 5, which is itself Fred. Now again, by giving people permissions at a schema level, that's permissions for everything that lives in that schema, past, present, and future. Everybody okay with that? So I like the idea of schemas. You do have to know how schemas work, and you can manage SQL Server perfectly well with schemas, and then you won't have to worry about alter or add yourself to the list of people that want create or replace in SQL Server. Right, that's one of the most asked for features is the create or replace verb, like Oracle has. Questions about that? Okay, great. So let's see, what else do I want to do about schemas? I think I'm going to stop at this point about schemas. And what I'm going to talk about now is finally one of the most confusing things about SQL Server, ownership chains. So people have heard of ownership chains? Okay, there's one person that's nodding at least. Everybody else? Okay. So in most databases, Oracle, DB2, I don't know about MySQL, any database that I know of except for SQL Server and Sybase, when a stored procedure executes, when you execute a stored procedure, that stored procedure executes as the owner of the stored procedure. So if you make up a stored procedure and the owner of that stored procedure has the ability to access a table, then they use the owner's identity to access that table. Everybody okay? That works perfectly well. And if you come from a database system like that, you absolutely think you know how a database works. However, in SQL Server, it's different. In SQL Server, the person who executes the stored procedure executes it as themselves. A stored procedure is always executed as the caller of a stored procedure. And the first time I told that to my wife, who's an Oracle DBA, she goes, no, that's impossible. Things would never work. You would have to give everybody permission to every table to let them access it. That's not possible. And in fact, of course that wouldn't be possible unless you have this sort of, workaround called ownership chains. An ownership chain basically says the following. If an owner of the stored procedure is the same as the owner of the table, permissions are never checked. And so therefore, let's demonstrate ownership chain. I have in the pubs database this user called Fred. And let's just execute as Fred to demonstrate that Fred does not have access to the authors table. So if I execute as Fred and say select star from authors, then Fred does not have access to this table. Great. So let's write two stored procedures. Actually, I can write three. One stored procedure we can write is a stored procedure that basically does a select star from authors. So get authors, and then as create procedure would be next spot. There, as select star from authors. And this type of SQL is called static SQL. It's part of a stored procedure. The select statement is absolutely directly in SQL in the stored procedure. And everything's okay. So at this point in history, if I revert back, because of course, would this work? I'm Fred. So create procedure get authors would try and create procedure DBO get authors under the guise of Fred and would fail miserably. I have to revert and create it under the guise of me, the DBO. So when I create a procedure called get authors here as select star from authors, then this is a perfect candidate for an ownership chain. I, the DBO, own the authors table, and I, the DBO, own the procedure that's using the authors table. Everybody okay with that? That means that when anybody executes that, and they do need execute permission to execute that, permissions are never checked at all. No. This bothers security people, right? Permissions are never checked. Bothers me as well. They are actually trying to get rid of ownership chains because it is a way to sort of circumvent the security system. But DBAs like ownership chains, and this is why. So let's create another procedure called getAuthors2. And getAuthors2 will maybe do dynamic string concatenation, and then execute the string with execute, right? So we'll execute a string in here with execute. Notice it is exactly the same code, but in this case, we're executing a string with execute, and in this case, we're actually using static SQL that is actually programmed as part of our stored procedure. This is dynamic SQL, this is static SQL. Everybody good? And so this proc will actually create just fine. So the difference between getAuthors and getAuthors2 is in getAuthors, the DBO owns the authors table, and the DBO owns getAuthors. We never check permissions. In this getAuthors2, the DBO owns getAuthors2, but nobody owns a string. There's nothing that they can check at execution time to see who owns the string. Therefore, the ownership chain is broken, and when they try and execute the authors table, they'll try and execute it as the caller of the stored procedure. And there's another variation of this as well. Suppose you have, I'm going to trip over this one day, you have a user named Alice, and Alice owns her own table. For the sake of argument, I'm not going to code up Alice. And so you as the DBO create a stored procedure that actually accesses Alice's table, right? Since the DBO owns the stored procedure and Alice owns the table, that's another breakage of ownership chain. And therefore, giving people execute permission is not going to be good enough. Okay, I'm trying to cut down the coding here because I have about 3 minutes. So people have heard of ownership chains before? Okay, just in case you haven't. So we will grant execute on getAuthors to Fred, and we'll grant execute on getAuthors2 to Fred. So Fred has the same permission on both. And so when Fred tries to execute select star from authors by himself, he doesn't have any permission to that table. And you can see that right there. But when Fred tries to execute getAuthors, getAuthors uses the ownership chain concept to say that permissions against the authors table are never checked. And so that works just fine. Now what about the one with the dynamic SQL in it? Well, dynamic SQL one, because nobody can own a string, actually fails miserably. And I swear this is the reason why DBOs like ownership chains. Because you take your stored procedure with the dynamic SQL and you say to the DBA, why doesn't this work? And I've actually heard DBAs say this to people, right? Not that there's evil DBAs, but the DBAs will say, well, it's because dynamic SQL is evil. And SQL Server knows better than to let you use dynamic SQL because it's a possibility for a SQL injection attack. Well, that's not the reason why, right? The reason why is because dynamic SQL breaks an ownership chain. And so therefore, this is not going to let you execute something because the owner of the string is not the same as the stored procedure. And if you think dynamic SQL is evil, that's a good story to make up, but that's not the reason why. Everybody okay with that? A lot of people who are not DBAs believe that ownership chains are evil. How come? I can deny you permission against the authors table, right? And a deny is supposed to trump all. So let's deny, select, dent, deny, come on, select on authors to Fred. Now we have made an explicit, declaration that Fred is not to get to the authors table under any circumstance. There, was it on? Sorry. On authors to Fred. We've just made an explicit statement that Fred is not to get to the authors table. It's something he shouldn't be allowed to do. However, once I am Fred, obviously I can't do this, and I can't do this, but I can do this. That works just fine. So ownership chains, because they never check permissions, circumvent denies. Security people don't like ownership chains, want them gone. However, if they're gone, execute as caller won't work right. You can't use a stored procedure to encapsulate that concept, right? To give them access to the procedure without giving them access to the table underneath. So database administrators want ownership chains to stay forever. They don't care about this, right? If you granted execute to Fred, that's anything that procedure touches. And by the way, one more thing about ownership chains before we finish. An ownership chain lasts for as many stored procedures as you call. So suppose Fred calls stored procedure A, they call stored procedure B, they call stored procedure C, and those are all owned by the same person, right? A, B, and C is owned by the same person. So you get down to C, executes a dynamic SQL statement, select star from authors. The authors table permission is not checked against the owner of C, or the owner of B, or the owner of A. It's checked against the original caller all the way up the chain, which is Fred. Everybody all right with that? So let's see, how can I summarize this when I stopped in the middle? Basically what we talked about today is we talked about the concept of SQL injection, how to secure your connection strings, how to guard against SQL injection, because that's the first thing that people configure incorrectly in a database application. The second thing is we talked about specific super users that you should never let applications run as, and everybody does, right? By the way, a way to make sure that they can run as anybody other than sysadmin is don't test as sysadmin either, right? Usually the reasons why applications run as sysadmin is because programmers will test as sysadmin, and then when it's a deadline and you have to put that code in, that code only runs as sysadmin. And it's like, no, we have to have that code in tomorrow. It's a legal requirement by the banking authority. And so DBAs will go along with that. Well, there's a business rule in here, right, that says the business matters. And so a best practice is not ever to test as sysadmin either. Sysadmin doesn't, go by the permission system. It bypasses it completely. And the same thing with DBO. Don't let anybody run as DBO in a real application system, and don't test as DBO, because there's no way you can limit the permissions for DBO. And luckily with sysadmin and DBO, although you saw before, not with Bob, who is sysadmin, if you actually try and deny things to them, they'll say you can't deny things to SA, or DBO, or sysadmin, or anybody else. Everybody okay with that? We also talked about separation of users and schemas, and users and schemas are separate so that you can give people permissions, but if they don't have a place to put objects, you can't put objects there. Also, users and schemas are separate so that you can give people permission to everything on a schema basis, and then dropping and recreating the objects within that schema has no effect on their permissions. They have permissions on things past, present, and future. We talked about some special users, and we finally ended up by talking about ownership chains. So is there any questions at this point? You should have at least a starting point of what you need to secure your database application. Okay, well, I therefore declare the day over. And I'll see everybody at the event afterwards if you're going to that. Thank you for coming. Oh, and I forgot this the last time, so make sure that I don't forget it this time. You're supposed to use the app to do the rating system on the app. So I don't know if there's a prize for doing the rating system and they pick the prize for one rating or whatever, but use the app to do the rating system. And by the way, if you don't have a device that the app runs on, then you have to use the web to do that. Right? I was sort of surprised when they said, tell everybody to use the app. The app seems really device specific. Since this is a Windows conference, you do have one for Windows Phone as well. And they said, no. So anyway, thanks for coming. And if you're interested in more SQL, I'll see you again tomorrow. I'm actually talking tomorrow about two things, one of which is really interesting but complicated, and the other one is sort of interesting from a point of view of if you want to stay in this world forever. One is about the cardinality estimator. And the cardinality estimator is fairly complicated. The cardinality estimator is what helps make up query plans. The other one is when you move to the cloud, notice I said when, I didn't say if. When you move to the cloud, do you want to use Microsoft Azure SQL Database or SQL Server in a VM? And that doesn't mean Microsoft Cloud. If you're moving to the Amazon Cloud, you can use SQL Server in a VM there as well. Okay, of course, the easy out that everybody always tells me is, how do we have a requirement that we can't be in the cloud? Remember, Microsoft's newest CEO was head of cloud as well. Okay, see you at the party and maybe see you tomorrow. Thank you. Kind of thing. But first I figured because it was a talk about SQL Server security, and here's way too much about me, one line at a time, right? I work for with a company called SQL Skills. They have a website, I have a blog. There's my email, there's my Twitter account, and various and sundry other things about me, which have nothing to do with this particular presentation. Although, like I said, I did do the security best practices white paper, so for a while. So I'm going to talk about new features in SQL Server security only because people like new features. I like to talk about new features too, so much so that I'm known as the shiny new feature guy, sometimes derisively, but I'll tell you about the new features in security for the last 3 releases. And then we'll talk about SQL injection, authentication and authorization, and a little bit about encryption, and if we get to it, auditing. So in SQL Server 2008, they added the ability to encrypt an entire database, and that's called transparent data encryption. Once you encrypt an entire database, you have the ability to write encrypted backups. Having said that, this was an enterprise-only feature, the encrypt the entire database feature. And so in SQL Server now, there is actually a tool called SQL Server Backup to the Web, which is a free tool. It turns out you can not only back up to the web, I should show you how the tool works. You can not only back up to the web, but you can back up with encryption from any release of SQL Server and, well, back to 2008 and maybe 2005, and with any addition of SQL Server. So having said that, even though it's not part of the presentation, that sounded interesting enough so that I should show you this tool. Billy, you're not supposed to do stuff on the fly. Okay, so you download this tool and you install it. And basically it puts a little hideous looking icon on your, sorry, we need magnification. Puts a little hideous looking icon on your tray that looks like it's a cloud with the database next to it. And so when you bring it up, it says Microsoft SQL Server Backup to Windows Azure Tool. And what I want to do is actually not back up at all to Azure because I don't have any network. I didn't think I would need it. We'll set this to actually back up from any addition of SQL Server to any, just a regular share or a regular directory. So what you do with this thing is you add rules to it. So we'll add a rule that says whenever I back up to a specific path on the local machine, or let's just do all paths to the local machine, with a backup pattern that's something like star.bak. So any backup that starts with or ends with BAK, sorry. What it actually can do is redirect to Windows Azure Storage. So this is a way to get people to use Windows Azure Storage. And you can do this with any release back to 2008. But you can also just use it with local storage. And so if I'm going to back up any local backup, it's going to redirect it to local storage. Well, what do you mean redirect? Why do we need that? So if you go to the next part of the rule, this part of the rule says it will actually enable, or can actually enable encryption, and it can actually enable or disable compression, which is interesting when you use Windows Azure Storage, but it's even more interesting in the fact that this works with any of the enterprise feature. 2012 had a lot of new features for SQL Server security. So a bunch of new permissions and some user-defined server roles. You could always have user-defined database roles, but this is user-defined role on a server basis. Default schema for Windows group users. I'll talk about schemas later on, because I actually really like managing SQL Server with schemas. And contained database. A contained database is a database that you should be able to move from place to place to place. And one of the problems with moving databases from place to place to place is that the logins are actually on master database. And so you have to move the logins separately. And this was a database that you could move around and users that could actually use their user ID to log into the database. Key algorithm changes. So they introduced encryption in SQL Server 2005. And when they did that, there's some old key types that they allowed. So they've started to migrate toward the new key types and get rid of the old key types. Key management enhancements. You can basically take public-private key pair and actually put it out to a stream of bytes so that you can take that stream of bytes and move it to another database. And auditing enhancements. So the problem with the original auditing was that it was an enterprise-only feature. People didn't like that. So they divided the feature into server-based auditing and database-based auditing. And they let server-based auditing do a sort of less granular version of database auditing. So basically, if you know how to code the statements, you can pretty much do everything with server-based auditing that you can do with database auditing. So that means you can, and server-based auditing is available from any scoop, any version of SQL Server, Enterprise or Standard or Express or anything else. So that's supported in any scoop. In 2014, they didn't do a lot, but what they were trying to do in 2014 was to make it possible to have users that were not super users that could manage the computer, manage the database, without having access to certain parts of it which they shouldn't have. So one of the things that I'm going to talk about is never to run as SA or anybody else at sysadmin, but it's actually not good to administer the machine that way either. This is as the man sits here and does demos off of as he's logged in as SA or a super user. So there's a super user login, and you can add a user that's part of that login group, and that login is called sysadmin. And if you're sysadmin, all security is off. There's nothing that you can keep away from a sysadmin at all. When they get to the part in the code that says check to see if the person's able to do this, if it's sysadmin, they just skip that code. So basically, once you have sysadmin, you have everything. So the premise was make a permission that's really high permission, like sysadmin, and the one they have is alter server, and then make permissions that you can take away from that person, that you can deny that person. So basically, the first one they had to worry about with this was impersonate any login, because even if you have the SA account disabled, if you're able to say execute as login equals SA, then you're sysadmin anyway, and so it doesn't make any difference. Also, they tried with, then what they will actually do is use a self-signed certificate. And for people that aren't familiar with that term, a self-signed certificate is one that's actually vouched for by the machine itself. So basically, I could take Bob's pirate server and put it out in the middle of the internet and give you a self-signed certificate and say it's anybody I want. And then if you encrypted that with that and sent back your user ID and password, I now have your user ID and password. So there's a connection string parameter that it always should be used if you're using Windows Azure SQL Database, and that's trust server certificate equals no. If somebody sends you a self-signed certificate, which is what the server certificate is at that point, you don't want to trust it if it's from Windows Azure. And actually, if you're on the internet, you shouldn't have that type of authentication either, because it's just insecure. Everybody okay with that part? Good. And then SQL injection. So it turns out the #1 cause of problems in web applications, which are most applications these days, are SQL injection problems. And you've probably heard of this, but I thought I would tell this story anyway. Everybody always, has heard of this story. You guys have speed cameras here. And so basically there's speed cameras in Seattle, and there's a lot of them, and people get tired of speed cameras. And so there's a guy that actually had a license plate printed up that says 1 semicolon drop database tickets, just in case they happen to feed his stuff into the database with this. By the way, I heard late after that, nobody laughed. I heard after that, because everybody's heard that thing. There is such a real person too. I heard that this is not a problem with MySQL, because MySQL doesn't allow multiple statements in a batch separated by semicolons. But with SQL Server, it actually is a problem if you actually concatenate user input. And the big thing about this is don't concatenate user input to make a SQL statement. Right now, if you do concatenate user input to make a SQL statement, and you're running as SA or sysadmin or whatever you want to run as, pretty much all bets are off. They can drop database tickets. And by the way, I guess the guy didn't have the ability to put drop database tickets with rollback immediate, because that'll get rid of all the people that are on that database before it drops it. So you can certainly do that even though people are using the database. So a best practice is, and it's funny because the DBAs are the ones that enforce this best practice, but the DBAs use string concatenation all the time. And I'll show you why coming up in a bit. But this is usually caused by concatenating user input to form a SQL statement, and it results in execution of whatever the user types in. Now, some of the results is that you can guess passwords, you can obtain passwords, you can obtain data that you're not supposed to obtain, you can obtain database metadata, although starting in SQL Server 2005, as long as you have the right low privileged account, they will not have access to database metadata, except for specific tables that you have the ability to access. again, this is another one where if you're using SA or DBO, all bets are off. And of course, drop database objects, drop database tickets. So some of the common patterns of select all user securables. They said this one was for auditors that needed access to user securables, but it was also to take away from DBAs that shouldn't be in user securables. It turned out that that one has a couple of rough edges. One is if I do have alter server, I can actually, or control server, I can actually make myself DBO of a database. And DBO of a database can bypass security in that database. So that's kind of interesting until I make myself DBO of a database. And this one also, unfortunately, doesn't allow you access to anything that's not part of the sys schema. So if it's part of the sys schema, you can access it, but anything else you can't access. And the problem is a lot of the ancillary tools that go along with SQL Server, like SQL Agent and SQL Mail, they actually live in schemas other than the sys schema. So there's kind of a couple of rough edges on this now, but that's what they introduced for SQL 2014. And again, encrypted backups without TDE. That's the little tool I showed you before. And that's a standalone tool. You don't have to have 2014 to get it, and you can just download it today. So what I'm going to talk about here is just sort of more application-y security stuff to start with, and then I'll feed into the authentication and authorization part of SQL Server. So basically connection strings. Believe it or not, in SQL Server 2005, they thought that one of the main problems with SQL Server was that all the demo code had hard-coded connection strings in the demo code that used SA and no password as the login. And people were too either lazy or didn't care to change the connection strings. And instead what they do is they'd actually change the SA password to no password so the demos would work. So starting in 2005, they basically rewrote all the demos that came with SQL Server so that they didn't go to SA with no password by default, and put those connection strings in a configuration file to sort of show everybody that really your configuration file should have your connection string, not your code. So it's a best practice to keep connection strings in a configuration file rather than program code. And if you have the config file in .NET, you can actually encrypt those so that even if you have passwords that are in those files, you can encrypt them to not be able to be seen. And then finally now it's called Microsoft Azure SQL Database. I didn't change all of my Windows Azures to Microsoft Azure last Thursday when they changed it again. So if you're using the Microsoft Azure SQL Database, that's a database on the cloud. No, I'm not going to do cloud without that. That's the database that's up on the cloud by itself. And the deal is that you authenticate to that with a user ID and a password, because right now they don't have active Windows Azure, Microsoft Azure Active Directory hooked up to that. So basically when you do that, what you do is there's a pre-authentication exchange where they will actually send you back a certificate so that you can use that to encrypt a response back. And what SQL Server normally does is if you have a certificate installed, they will use that certificate and that'll be secure. You do have to have a certificate on the other side to be able to talk to it. If you don't have a certificate installed, so if I enable encryption, I have to put in a password. Password cannot be empty. I wonder if it can be password. Son of a gun, it can. Okay, well, anyway, the password can be password, and then you can enable compression at the same time. And basically how this works is rather interesting. So you make up this rule, there we go, and now that you have this rule, the tool goes away. And when you actually go to do a backup, this backup automatically is encrypted, and how would you think this would work? Especially with older versions of SQL Server. So here's how it works. There. So if I go ahead and go into the database and just pick a database at random, a small one, so it won't take forever, like the pubs database, and back up this database, there we go. It comes up with the usual backup thing. And I want to back up to not something that's C Azure backups, but T local backups. So we'll just do a full backup to the local backups directory. So we don't want that one, because that's actually set to point to Azure. We want this one. We decided that people really wanted to have, and this is pubs.bak, people really wanted to have something that would back up automatically. And actually, let's call this pubs3.bak, just in case I've done this before. And the only problem with this tool is it won't work in low resolution. Well, Go. Okay, good for me. And it's got that destination, fine. Okay, great. And we don't want this one in here. And now when you go ahead and back up, notice I'm using the regular backup tool, and I've specified encryption. So what happens if I go out and look at what I backed up and where, it turns out that what I backed up and where is a PUBS3 backup that looks like a regular backup, but there's actually a level of indirection, and there should be someplace on my file system something called PUBS3 ENC, which is the encrypted backup. And so basically it looks like you have a regular backup, and you can restore from a regular backup, and as long as that tool is in place, it knows where to get the encrypted compressed one. So that's actually kind of cool, I think, with any release of SQL Server and any addition of SQL Server. Okay. So that was for enterprise. This is for everybody. And built-in auditing was another feature in 2008. People have written all kinds of auditing things in the past, and usually when they went to try and get the auditing certification, they said you should do auditing from SQL Trace, from SQL Profiler. And the problem with that is it's a separate tool, it's really not secure from the people that are using it. And so in SQL Server 2008, they actually added built-in auditing. And so that is, again, an enterprise feature as well. External key management. So when SQL Server instituted encryption, one of the things that they did was store the encryption keys on the database with the data. And that's not a security best practice. You're supposed to store the keys separate from the data. And large organizations have these things called external key modules that basically do key management. It's like a box that looks like a set-top box for a TV set. And so they made it so that you can use these modules, and they have a couple of these modules that work with SQL Server. Again, another